Okay, in this example, there is a marketing research firm. They are conducting a study to determine if there is a relationship between individuals' age and individuals' preferred source of news. The research firm asked 1,000 individuals to list their preferred source of news, a newspaper and radio or TV and internet. So the following results shows the following. So we have the count for each group. So found out that people who are preferring newspaper, age group 20 to 30 is 19 individual and so on. So we do have this table and we would like to study whether there is a relationship between both groups. So because the variables that we have, if you look at the variables, the first one, the preferred news source, it contains 3 levels. So it's categorical. The measurement is nominal because we have 3 levels. The order doesn't matter. There's no number. So they just sample 1,000 individuals randomly. They ask them a very simple question. What is your preferred news source? Simple. And they give them 3 options: newspaper, radio, or TV. So they just check one of them. And the second variable, so the first variable is categorical nominal. The second one, the age of the respondent. And again, it's categories. We have categories. Probably it wasn't categories. The data were collected raw data in a way that they have a continuous age, but they group them. Which is fine. So they group them because it helps them to specify or help them in their research question. So they have groups. We have groups, 4 groups again. We have 4 levels, and this is ordinal categories. So the first one is the smallest one, the second one, then third and fourth one, right? So because we have 2 categorical variables and we are studying the relationship, if there is an association between age of the respondents and their preferred news source, then we are going to use something called contingency analysis, or the analysis of independency, or the analysis of the association. In this case, we use chi-square test or the Fisher's exact test, which is part of the chi-square, which is in the same group of the chi-square. So what is the null hypothesis? It's going to be the age of the individuals is independent of the individual's preferred source of news. However, the alternative hypothesis, the age of the individual and their preferred sources of news are not independent. And we can ask this question, or we can ask like the first variable is associated with the second one, like the age is associated with the preferred news source. Or we can say the alternative, the age is not associated with the preferred news source. So we can set up different like hypotheses. I mean, the wording can be different. Okay. So what I did first, I put this in Excel sheet. Then I actually write because I do have the count. I don't have the raw data. So what I did, I arranged the data format, which is the row column, the count, or actually this can be, okay, the question is, the preferred news source and the age group, which one's the independent? Which one is the outcome? This is the independent. The age group is the independent one. This is the outcome. This is the outcome, right? So this is independent. This is the outcome that we're expecting people to choose from. So many books say that for the outcome, it's good to be in the column, and this has to be in the rows. So actually this should be flipped. Okay. So what they are saying that this is to be in rows. This has to be in the columns. So we are going to add the count. To do that, we are going to go to statistics and table analysis. And we are going to choose my file. In this case, I do have the chi-square file. Then what is my row variable? In this case, I'm going to follow the convention, the book that use, which is going to be the row is the predictor, which is the age group. The column is going to be my preferred news source. Then because I do have the counts, I have to report the counts as a frequency counts here. Then I go to options. I don't want to have any plots. So I'm gonna remove the plots. I would like to see the observed, which is what we have right now, the table, and the expected from the chi-squared. Also, I would like to see the difference, the deviation between the observed minus the expected. You can report the cell, row, column percentages if you want. I don't actually, or you can do that for the cumulative totals, the percentages. You can report any of these and look at them. And also you can report the contribution for each cell of the chi-squares. But I'm going to keep the chi-square statistics. Also, if you have 2x2 tables, you can report the odds ratio and RR, the relative risk. It depends on your study. If it's cohort study or case control study, then you can actually report one of them. It depends on your study. Right now, I'm going just to keep this one because I don't have 2x2 tables. I have more than 2x2 tables. Also, if we have limitations, if you have issues with chi-square, then we are going to report the exact Fisher's exact test. And one of the limitations, when we got the expected value to be one of the cells in any of the cells, if the expected value is less than 5, then we report Fisher's exact test other than the chi-square statistics. Actually, when you have a very small set of data or a small sample, we report Fisher's exact test. In this case, we have about 1,000, so chi-square is going to be sufficient. Okay, run. Let me make it bigger. Why this is small, I think. Okay, here we go. So I have two tables. The first table, because we added, this is the observed, the first one. The second one is the expected. This is the expected. This is the deviation. And these are the expected values. And these are, what does it mean by the expected values? These are what we would see, whereas if there were no association between the variables. If we are assuming the age and the news source are independent, completely independent, with no relationship, so this count has to be happening. Okay? The expected values, these are the guys that we're expecting. If there is no association, if they're completely independent, this is what we are supposed to see. Okay? And this is the deviation between the two numbers. This is 104, but we are expecting this to be 40. So the deviation is 63. This is 19. This is 48. So the deviation or the difference or this subtraction is negative 29 and so on, right? So this is what we are getting. And actually we can tell. I mean, if you look at the raw data at the beginning, before doing anything, if you look at just the frequencies only, the frequencies, can tell that this age group 20 to 30, 104, 19, 27. It makes sense. So 20 to 30 group, the age source of information comes from the internet, majority. 31 to 40, the majority comes from the TV. Then the internet, slightly very close to each other. And 1 to 50, the majority goes to TV. Over 50, the majority goes to the newspaper. So all these numbers kind of, when we collected them, make sense. If there is no association between both the groups, both variables, then we're expecting the values to be like this, the second row, okay? The question is, what is the null hypothesis? We said that the null hypothesis that there's no association between the age and the preferred sources of news, or they are independent. The alternative hypothesis is that no, there is kind of what's so called a relationship between both groups. Does that make sense? If you look at the chi-square, now we look at the second table. The second table is going to tell you what? It's going to tell you whether we reject the null hypothesis or we fail to reject the null hypothesis. Reject the null hypothesis, this has to be less than 0.05. We have three different tests, by the way. Chi-square, the likelihood ratio chi-square, and the last one, which is the mental chi-square, or these are two guys actually. The sample is large. It's enough to report chi-square. All of them are significant, by the way. This is a different test. Actually, to use the log, different calculations, different way of finding the associations or the probability actually, and the value. If you report the chi-square, this is sufficient. So the probability or the p-value is less than 0.05, which is we reject the null hypothesis. This is the chi-square value. Usually we report the chi-square value between parentheses, and we report the degree of freedom, and we report the what's so called the p-value as well. So we report these three values when we write the report. What else? So we reject the null hypothesis. Also, what I wanted to say. So there is actually, if you reject the null hypothesis, so we do have an association between the age of respondents and the preferred news source. We do have an association. We do have something. The age tells something about the preferred news source. So if you're marketing research and you would like to invest some money to put training, whatever, you have to know what you are attacking, which group you're attacking. If you're focusing on this age, for instance, you have to go to the internet. If you're focusing on this age group, you have to think about either that one or the last one, and so on. So it depends on what you are, what is your goal. Now the question is, what is the effect size? Because when you have a big data, a big sample actually, because this is 1,000 sample size, 1,000, right? So when we have a tiny associations, can give you actually a tiny p-values as well. So we have a follow-up test, which is the effect size. The effect size, we have three effect sizes here. I'm going to focus on Kramer's V. This is a very common one. This is a very common. And we follow Cohen's criteria. So this number is about, this number from 0 to 1, all of them from 0 to 1. This is from 0 to 1, which is about 0.39. Based on Cohen's conventions, this considered a moderate to kind of a strong association. So we do have a moderate and strong association between both variables. And the age really does matter for the news preferences. And the question is how to read. How does this matter? Just look at the raw data or look at the differences. You can run the column and frequencies and the percentages. You can run these. Or the cell. I mean, you can run the percentages and read them. So these are the percentages, raw percentages, column percentages, or you can keep the raw data and just compare them, okay? And you can easily tell that the age group, 20 to 30, we have to focus on the internet. 31 to 40, we have to focus on, we have a big deviation here, actually. The internet and probably the radio, although there is a small deviation here. 41 to 50, we have to focus here. 68, there's a big difference, big gap. Over 50, we have to focus on also this one. We have to avoid internet for these guys. It's negative. It's big number, big negative. We have to avoid internet for if you are targeting over 50. You have to avoid 41 to 50 for the internet as well. If you are targeting this group. Also, if you are targeting 20 to 30, you have to avoid these two sources, big differences. This is what we can tell, I mean, from this table. So that's everything. And if you actually have 2x2 table, you can, as I said, you can add the odds ratios and relative risk. And it depends on your study, if it's cohort study or the other one, case control study.